Good morning to all. Myself Arul Soumya, working as an assistant professor in Department of Information Technology. So here I am going to discuss about a topic on generalization from data in Introduction to Data Science. So generalization from data in data science is the topic we are going to see here. That is simply making models work beyond training. So firstly, what is generalization in data? So imagine your study from your textbook. So in that exam, you don't get the same question, but you still answer using what you have learned. So this ability is called generalization. So same way in data science, we train a model with some data. That is, if the model can make correct predictions on new unseen data, it means it generalizes well. So next is why generalization matters. So why generalization is important. So think of a spam detector in Gmail. So if it only blocks the spam emails it already saw during training, it is useless. So it must identify new kinds of spam emails also. So here the generalization turns a model from a classroom project into a real world solution. So the next one is training error versus test error. So training error in the sense here it mistakes the model that makes on the data it learned from. Test error in the sense mistakes it takes on new data that is more important. So if training error is low and test error is high, then the model is overfitting. That is memorizing, that is not learning. Next one is the generalization challenge. Here the generalization challenge has two types, which is overfitting and underfitting. So these are the two common problems we are going to see. So first one is overfitting. Overfitting in the sense here the model memorizes everything, even noise, and it performs well on training the data but bad on new data. Like a student who memorizes answers but cannot handle a new question. So next one is underfitting. Here the model is too simple that it cannot learn the important patterns like a student who didn't study enough. So next one is good model, that is should be between both, that is not too simple and not too complex. Next one is theoretical foundation. So theory behind generalization. First one is bias variance trade-off, and second one is Occam's razor, and third one is statistical learning theory. In bias variance trade-off, bias is equal to error from too simple model, and whereas a variance is equal to error from too complex model. So here a good model balances both, which is under bias variance. Next one is Occam's razor. So in Occam's razor, the simple models are preferred when two models perform equally well. The next one is statistical learning theory. Here, the mathematical framework explains how models learn and how much error to expect. The next one is techniques to improve generalization. So what are all the techniques here? The first technique is regularization. The second one is cross validation. Third one is early stopping, and fourth one is assemble methods. In regularization, we can add a plenty for making the model too complex. And in cross validation, we split the data into different parts to test the model many times. So in early stopping, we can stop the training when performance stops improving to prevent overfitting. And last one is ensemble method. In ensemble method, we can combine several models to reduce the error, like taking average opinions. Next one is data generalization. So data generalization means simply it is simplifying the data. So sometimes we do not want exact details, we just want broader categories. For example, instead of keeping exact ages like 32, 35, 38, we can group them into 30 to 39. So this protects privacy and it helps us see trends and it makes data simpler to analyze. So the next one is visualizing generalization. So visualizing generalization from specific to general. Here step 1 is raw data, step 2 is group data, step 3 is trend analysis. So in raw data, which is step 1, we can make an exact numbers like 32, 35, 38. That is an individual age values of a person. And in step 2, which is grouped data, we can decades the 30 indicate forms like 30 to 39, 40 to 49. And the next one is trend analysis. In trend analysis, we can easily see patterns like which age group has more people. So, coming to the last one, which is a generalization, is the heart of practical data science. That is why model generalization and why generalization is the heart of data science. Here, modelization first we can see modelization, generalization. That is, we can see a real life example like a spam model, which first memory spams emails, but over time it starts understanding patterns. So it begins catching new spam types automatically. So this is called real generalization. So comes to the understanding, trust, impact, and innovation. So these are the four types which comes under the generalization is heart of data science. Why we are predicting here. In understanding part, the models really understand the patterns. In trust part, we can rely on its real world situations. And in impact part, the organizations can make correct decisions using predictions. And in innovation, it helps create intelligent AI system, not just memorizing the ones. So that's all about how a generalization matters in data science. Thank you.